Hi, my name is Ryan Booz. I'm a solutions engineer here at pganalyze. And today I'd like to start a series with you looking at pgstat statements, taking a deeper dive into exactly what it is, what it isn't, how it can help you, and sometimes how it can let you down if you don't understand exactly what's going on. Let's go ahead and get started with episode 1, looking at exactly what pgstat statement is and what it might not be. Now, first, let me ask you this question. Have you ever said any of these things as you're trying to manage your Postgres database? Oh my goodness, my database is slow right now. Which query is using all the resources? Hey, over the last 24 hours, can you tell me which queries on average take more than a second to execute? Or what about, hey, some of these web pages are loading pretty slowly. Can you show me which queries are called a lot, but take a couple hundred milliseconds to execute on average? Those queries that might be contributing to your web pages loading more slowly? These are common questions. These are things we need to know as database engineers, as DBAs, as the developers who are trying to make these applications work really well with our database. And the answer has almost always been, sure, we can show you that. Go use pgstat statements. And that answer is almost always true. Now, what is pgstat statements? It is an included extension. These come from what we call the contrib modules. It's a set of extensions that are part of the open source project of Postgres, and they are essentially included wherever you install Postgres. Now, it doesn't mean that they're all activated, right? So they are available, and specifically pgstat statements, as far as most people are concerned, it really should be available in any installation where you use Postgres, whether that's in a cloud provider, whether that's in a Docker container, or whether that's in just a bare metal install that you've done. It is there. It just needs to be activated and made ready. Now, pgstat statements, the metrics that it holds is actually done in an in-memory hash table per instance of Postgres, not per database. So there's one instance of this hash table for every database within a Postgres instance. And it tracks per execution query metrics. And there's a lot of them. Now, to enable pgstat statements, it does need to be configured within that Postgres instance. First, you need to have it configured within the shared preload libraries configuration variable in the postgresql.conf file. Now again, if you're using a cloud environment, some of them have started to enable this by default, but all of them give you some way to edit this configuration setting within Postgres. And then, on at least one database within that server, you need to actually install the extension through the create extension command. And once that's done, once it's in the shared preload libraries, and once the extension is installed, you can begin to look at the data. And it tracks things like a unique query ID for every normalized query text. It tracks the actual query text, the calls, total time, the mean runtime, how many rows were selected for that statement, locks, blocks, planning, all kinds of things. In fact, as of Postgres 18, there's at least 45 columns in this view when you select from it. There's a lot of data, and it can be really helpful in finding the problems or those queries that need your attention. One of the problems, however, is that all of the queries in this view, and in fact, many of the Postgres views, are cumulative, but only cumulative since the last time a query has been tracked. You heard me, since the last time a query has been tracked. Up until now, we've almost always talked about things like the metrics are there until the server restarts or until you specifically reset the metrics. Why would you reset the query metrics? Well, the reality is pgstat statement has been around for at least 2 decades. And these in-memory hash metrics are really intended to be essentially a quick point in time way to discover queries that might be having an issue. So for years, when someone would say, hey, my server's slow and I need to find the query that's impacting it right now, the community would say, okay, this is how you find that query. My performance is slow. Okay, go ahead and execute the pgstat_statements reset command, and that resets all the metrics. And then for a few minutes or seconds, whatever the time period is, just keep selecting from this view and see which query is using lots of resources. Now that you've identified the query, go find that in your source, optimize it, and then when you update that query, go ahead and reset the statement metrics again and start monitoring it. It wasn't originally intended to be something that's sampled over and over for days, weeks, or months to track long-term query metric performance. And that was an aha moment for me. Because so many of us have thought, if it's run at any point in my usage of this Postgres instance, then there's data for it in pgstat statements. It turns out that's just not true. And there's so many things that contribute to this, things that we're going to talk about through the series. What it doesn't track, at least a high level, is this. It does not track per execution history. There's nothing that says this query was executed 2 months ago and here's the metrics for it, or it's been executed this much over some period of time. It is a cumulative view. It's not a per second, a per minute view. You have to, or the monitoring tools you're using, have to do the work to go ahead and figure out what those changes are over time through the deltas of those cumulative metrics. But one thing we have to really make sure we understand is it does not track every query forever. In fact, at any one time, it is only able to track the pgstat statement .max setting. And by default, that's 5,000 unique query texts. And the real issue is what happens when it reaches that 5,000 unique queries. I didn't understand it until just recently, and I'm hoping through the series I'll be able to help you understand it better and what problems can occur if you don't understand what's happening here. When we think that pgstat statements is really our historical view of query metrics, at least since the server has started, we recognize that this can be a real problem in how we're viewing the data. It means that we often treat this as the single source of truth. If I need to find a query and how it's performed over time, I'll go to pgstat statements. That's not true. Monitoring tools depend on pgstat statements. It is the only query metrics view in Postgres available everywhere. And so every monitoring tool that is trying to help you learn what's happening with your queries over time are going to be sampling from pgstat statements. And if you don't understand when it can fail and what kind of situations mean that you need to modify settings, you could actually be flying blind when it matters most. You have a problem and you're trying to find a query that might be the issue. You might not be able to find it or the historical data for it in pgstat statements or your monitoring tool. And that's what we want to figure out through the rest of the series. Now, why does this really matter to me? Well, sure, first, I work for pganalyze. I think we have a top-of-the-line, excellent monitoring and query performance tool for Postgres. But there are still times where we have very big clients, ourselves included, that have thousands and thousands of unique statements happening at any period of time, at least within a day, in our databases. And there are instances where we begin to see something like this. And this is a real problem. When I started to dig and when I started to work with others in the company like Lucas to figure out why does this keep happening? Why can't we always find every query text that we're monitoring for within these unique databases, particularly as they get bigger and bigger? And what I found out and what I was able to understand more about pgstat statements blew my mind. And so over the next 6 episodes, we're going to talk about all of these things with pgstat statements to give you a leg up on better utilizing this amazing tool within Postgres. So in the next episode, we're going to talk about what that unique statement is. pgstat statements works on query texts, normalized query texts. What does normalize mean? We're going to actually go look at the source code to uncover some of these gotchas that have been misconceptions for years. And then we're actually going to go see, well, what about those query texts? Why can't we always find the full texts? Hey, the tool I'm using never shows me the full text. There's a ... at the end. I can't find all of it. We're going to talk about the configuration. We're going to look at some ways that high cardinality workloads are problematic and some things you could do to better utilize pgstat statements. And finally, we're going to talk about a few ways that maybe you can better utilize pgstat statements to get the information you need long term as you grow in your Postgres environment. So I hope you'll join me for the rest of the series. I hope it's helpful for you, and I hope maybe you also have one of those mind-blowing aha moments with something that's so essential to Postgres. Take care.